Okay, so for this problem, we have water that's flowing from the bottom of a storage tank at some rate given by this polynomial function. And the rate is in liters per minute. Okay, so that's important. Liters per minute. And we've got a time frame between 0 and 50. Okay, so this relationship holds for t equals 0 to t equals 50 minutes. And we're asked to calculate the integral of the function from 0 to 4 and give a practical interpretation of this integral, including appropriate units. All right, so let's do the integral. Integral from 0 to 4. And r of t is 0.08 t squared minus 8t plus 200. Okay, all of that, and then dt. Okay. So this is just a polynomial, so it's fairly easy to integrate. Okay, so I'm just going to put brackets here. I'm going to write the antiderivative. And so I got 0.08, and I'm going to have the integral of t squared is going to be t cubed over 3, right? Just add 1 to the exponent and then over 1 plus the exponent. Okay, and then we have minus 8, and the integral of t is t squared over 2. And the integral of 200 is just going to be 200t. Okay, and we're going to evaluate that from 0 to 4. Okay, so we got to plug in values. And that's kind of the tricky part sometimes. 0 is the arithmetic. It's a pain. All right, so we have 4 cubed over 3. And plus, okay, 8 over 2 is 4. So I'm just going to write that as 4 times 4 squared. And then plus 200 times 4. Okay. And then, you know what I'm going to do? I'm going to actually make that, change this, because I'm just going to apply, the fundamental theorem of calculus. So I'm going to take the antiderivative, evaluate the antiderivative at 4, and then subtract the antiderivative at 0. Now, you can see if I put in 0 to every one of these terms, that they're all just 0. So actually, I'm just going to erase that because we're done. Right? Now we just have to evaluate all of this mess. And this one does not ask for exact answers, so I can just put this in my calculator. And when I put it in my calculator, I get 737.7. And the units are liters, right? Because we're integrating a rate in liters per minute, right? So we have liters per minute times the units of the the variable, which is t, which is in minutes. And if I take, so to get the units of the integral, we multiply the units of the function times the units of the variable. Okay, so liters per minute times minutes just gives you liters. Okay, so we have 737.7 liters. So what that's telling us, okay, we gotta write a practical interpretation. So what that's telling us is that 737.7 liters of water, flowed out of this tank. So flowed from the tank over the time that we integrated, right? We integrated from 0 to 4. So it flowed over the first four minutes, right? From 0 to 4 is the first 4 minutes. Okay, so there's an interpretation of what that integral means.